Hey guys, welcome to yet another interesting session by Intellipaat, and today we're going to learn about R programming. So we'll start off by understanding what exactly is R language, and then we'll learn about variables in R. Following which, we'll learn about different types of operators, and finally, we'll work with data types in R. So let's get started. So what is R? R is a language developed by statisticians for statisticians. And thus, if you want to perform any sort of statistical analysis, R is your go-to language. R is also a great visualization tool. R provides visualization packages such as ggplot2, ggvis, and plotly to create stunning visualizations. And the best part about R is it is a Turing-complete language. That is, it can perform any task which a Turing machine can. R truly is an awesome language. So let's go ahead and install R in our system. So I'll just type out download R over here. I'll click on the first link. So this is the site, pan.rproject.org, and this is the latest version of R 3.5.1. And since I'm using a Windows system, I'll download it for Windows. Right, we have downloaded R. Now after installing R, we would also require an IDE to work with R. So one such IDE is RStudio. So we'll head back and also download RStudio now. I'll open a new tab and I'll type download RStudio. Again, I'll click on the first link. I would require the free version. And again, since I'm using a Windows system, I'll download it for Windows. Right, the download has started. Now we have installed R and we have installed RStudio. Now we'll go ahead and understand what are variables in R. Simply put, a variable is a temporary storage space. Over here, this box is a temporary storage space which can hold only one object at a time. We have an apple with us and we place it inside this box. After some time, we decide to remove this apple and replace it with a strawberry. Again, after some time, replace the strawberry with a tomato because tomatoes are the best, aren't they? And this is pretty much how variables work. These hold temporary values which can be changed again and again. Now let's go ahead and implement variables in R. So this is RStudio, guys. This is how RStudio looks like. We'll be implementing variables over here. So I'll just say A equals, let me actually change it and actually name the variable to be fruit. Fruit stores apple. Let me put in the value of fruit. Right, so the fruit is apple now. Now let me change the value of the fruit to strawberry. Now if I print fruit, the value is strawberry. Let me change it again. Now I feel like eating a banana. Right. So we see that the value has been changed to banana. So this is how variables function. We can keep changing the values again and again. So that was a simple example with variables. Now let's learn about different types of operators. Broadly speaking, we have arithmetic operators, assignment operators, relational operators, and logical operators. Now let's implement all of these in R. So we're back to RStudio. Now we'll start off with arithmetic operators. So arithmetic operators provide us with simple arithmetic functions. So let's say I want to add pi plus 6, which is 11 obviously. Now if I subtract 10 minus 5, I'll get 5. So that was addition and subtraction. Now let me divide 10 with respect to 5. The answer is obviously 2. Now if I want the remainder, then I will use a modulo operator. So 10 % symbol 5. Right, the modulo or the remainder for this is 0. Now we had seen the plus operator, minus, division, and modulo operator. These were the basic arithmetic operators. Now you can actually assign these values to variables and work with arithmetic operations with the variables as well. So what I'll do is I'll just say num1 equals 10 and I'll take the second number to be num2 and I'll give the value 5. Now over here I'll type num1 plus num2, and this is our result, which is 10 plus 5 equals 15. Let me subtract these. Num1 minus num2, which is 10 minus 5, is nothing but 5. Right, now it's time to multiply. Num1 cross num2, 10 cross 5 is obviously 50. Now let me actually take the power of this. So num1 raised to the power num2, that is 10 raised to the power 5, which is nothing but 10 power 5. Right, so these were the basic arithmetic operations. Now let's go ahead and see some assignment operators. Assignment operators are pretty simple. We just use them to assign the values. So let's just say game is a variable, and this is the operator over here. This is the assignment operator. Now, right, and this is how I'm assigning the value. Game is on. Now I can assign this way as well, game equal to on, or I can directly use the value and then give it to the variable game. Right, it's the same thing. So this was the assignment operator. Now let's go ahead and check out some relational operators. So the relational operators are greater than, less than, greater than equal to, less than equal to. Now let me compare num1 and num2. So num1 is 10 and num2 is 5. So let me check if num1 is greater than num2 or not. So num1 greater than num2. It gives me the value true. That is num1, which is 10, is obviously greater than 5. Now let me do the reverse. Let me see if num1 is less than num2 or not. Which is actually false, because 10 is obviously not less than 5. Now let me see if num1 is equal to num2. So num1 double equal to num2. And I see that num1 is obviously not equal to num2. Right. Now there is also an not equal to operator. Num1 is not equal to num2, which is again true. So these were the relational operators. Now we'll check some logical operators. So logical are simply and or. So let me give the value of let's say logic 1 has the value true in it, and logic 2 has the value false in it. So logic 1 and logic 2 right, so that is true and false. So true and false is obviously false. Now let me see logic 1 and logic 1, which is true and true, is again true. Now let me check logic 2 with logic 2. Just false and false. So false and false obviously gives me false. So AND operator gives me the true value only when both the operands are true. Otherwise it will just give me the false value. Now let us check out the OR operator. So OR will just give the pipe operator. So logic 2 and logic 2, that is false or false, which is obviously false. Now let's check true or true, which is obviously true. Now let's check true with respect to false, true or false, which gives us true. So this is how OR operator works. So these were some examples of logical operators. Now let's head back and understand what exactly are data types in R. The most basic data type in R is a vector. It's a homogeneous unidimensional object. So what do I mean by homogeneous? Well, all of its elements must be of same type. Like over here, we have a collection of birds linearly arranged. Now let's implement this in R. Right. So I'll create a vector and I'll name it as bird, and I'll give it some values. So the first element is parrot, which is my favorite bird. The next element is pigeon, and the third element is the mighty eagle. So we have this vector bird which comprises of three elements, which are parrot, pigeon, and the eagle. Now, when I said that a vector is always homogeneous, this is what I meant. So all of these three elements are of character type. So let me check the class of this. So I'll say class of bird. Now this is a character vector. Similarly, let me create a numeric vector. So numbers would be my numeric vector, and I'll assign the values 1 to 9 in this numeric vector. When I print this, so this is the numeric vector. Now let me check the class. Class of numbers. Right. So this is the integer vector or the numeric vector. Now let me create a logical vector. So log, I'll name it to be logic 100, and let me assign some values. So I'll say true, true, false, false, and false. So let me print logic 100 now. So this is the logical vector which comprises of these 5 elements, which are true, true, false, false, and false. Let me check the class. So this is class of logic 100, which tells me that this is a logical vector. Right. So we're done with numeric vector, character vector, and logical vector. Now let's see what happens if we mix one sort of data type with another data type. So let me name this as jumble, and I'll say 12, 24, and let me give the value of true over here. Now let's see what happens. So when I print this, what we see is this logical value true is turned into its numeric value, which is 1. That is, numeric values take precedence over the logical values, and hence we have the same class overall. Let me take the class again. This will be class of jumble, which tells me that this is a numeric vector. Right. Now again, let me create another vector over here. I'll name it as jumble2, and let me give some values. So let me say Nirvana, which is my favorite rock band. Let me give a logical value over here, true, and let me assign a numeric value, which is 100. Now let's see what happens. So I'll type jumble2 over here. Right, so this gives me a character vector, that is Nirvana. That is, character vector has the greatest precedence over other vectors. So first comes character, then comes numeric, then comes logical. So this is the order of precedence. Right. So this was vector in R. Now we'll head back and understand what exactly is a list. So a list is a heterogeneous collection of elements. That is, the elements do not have to be of same type, and each element retains its own identity. Like over here, we have a heterogeneous collection comprising of a bird, an apple, and a book. Again, we'll go ahead and implement list in R. So let me create a new list, and let me name this to be basket. So this is how we create a list, and I'll give a character value over here. So I'll say Sam, and I'll give a numeric value, let it be 500. I'll give a logical value, which is false. Now let me print this list. So this is how a list looks like. So we see that all of the identities of the individual elements are retained. So Sam, which is a character, stays as a character. 500, which is a number, stays as a number. False, which is of logical type, stays of the logical type. Right. Now what we'll do is we'll create two separate vectors and store them in a list. Let's see what happens. So let me create fruit vector. vector and let me add some fruits in it. First fruit would be apple, next would be banana, and the third fruit would be let us say grapes. So we have fruits over here, then we'll also add the corresponding cost. So we'll create a new vector, name it as cost, and give the values. So the values would be apple cost, let's say 100 rupees, a banana cost around 30 rupees, and grapes cost around 50 rupees. Right, so we have our two vectors now. Let's pass both of these into a list. Again, we'll name the list to be basket. Right, list. So the first vector was fruit, the next vector was cost. So this is what we see over here. So the first element of the list comprises of a vector. Similarly, the next element or the second element of the list comprises of again a vector, which is the cost. Now, what if we want to access individual elements of the list? How can we do that? Well, that is actually quite simple. So let's just say I want to access just the fruits. So what I'll do is I'll type out basket and I'll say 1. So this gives me the first element of the list, which is a vector of fruits. Again, similarly, I'll say basket of 2, which gives me the second element of the list, which is the cost for all of the fruits. Now, what if I wanted to access the second element from the first element, or that is this banana from over here? So this is how we can do. So I'll type out basket, and from inside the basket, that is from inside the first element, I am accessing the inner element, which is 2. Right. Now let me access the third element similarly. And again, similarly, let me access the first element. Right. So this is how we can access individual elements from the list. This was the concept of list. Next in line is a matrix. So matrix is a homogeneous collection of elements in two-dimensional space. So over here, all of the birds are arranged in rows and columns. So now let me go ahead and implement a matrix in R. So for that, let me actually create a vector. Again, I'll use the numbers vector. So this consists of elements from 1 to 9. Now this is how we can create a matrix. So we'll use the matrix function, and we'll give in the data, which takes in the vector numbers. And since there are 9 numbers, I would want 3 rows and 3 columns in. So I'll state n row equals 3 and n col is also 3. So let me print this now. So I have my matrix, which consists of 3 rows and 3 columns, and this was the vector. Now we see that these numbers are arranged with respect to the column. That is 1, 2, 3, 4, 5, 6, and 7, 8, 9. Now, what if I wanted to arrange the numbers with respect to the row? So this is how we can do. All I have to do is use the by row attribute and assign it to be true. Right. So what we see is the numbers are aligned with respect to row. So 1, 2, 3, 4, 5, 6, and 7, 8, 9. Right. So this is how we can implement a matrix. Now it's time to learn the final data structure, which is a data frame. So a data frame is a heterogeneous collection of elements in two-dimensional space. So over here, the first column comprises of fruits, second column comprises of birds, and the third column comprises of cars. So time to head back to R and implement a data frame. Now I'll actually create a student data frame over here. So let me type student name, and I'll add 3 elements to it. So the first student is Sam, the second student is Lisa, and the third student is Bob. So we have the names of the students. Now let me also add marks to these students. So student marks, let me assign marks to them. So Sam does not study at all, and that is why he scored just 10 marks. Lisa is a topper who scored 99. and Bob is an average student, got 55. Right. Now we'll give them their grades. That is, we'll check if they have passed the test or not. So I'll create a new vector and name it as student pass. Since Sam has scored just 10 marks, he has obviously failed in the exam. Lisa, being the topper, has obviously passed. Bob has just managed to pass the exam with 55 marks. Right. Now, let's create a data frame with these three vectors. So I'll create a data frame with the name student details, and I'll use the data frame function over here. So I'll give student name as the first argument, student marks as a second argument, and student pass as a third argument. Now let me print this. Right. Now we can actually view a data frame. So I'll say view of student details. So this is a data frame student details, which comprises of the name of the student, the marks of the student, and whether the student has passed the exam or not. And what we see is this is a heterogeneous data structure and comprises of three columns. The first column is of character type, the second column is of numeric type, and the third column is of logical type. Right. So these were all of the data types in R. And this also brings us to the end of this video. So let's have a brief recap. So we started off by understanding what exactly is R language. Then we understood what variables in R, following which we implemented operators in R. And finally, we looked at different types of data structures in R and implemented all of them. Thank you for watching the video. And if you're really interested in doing an end-to-end R course, then you can join Intellipaat's R training course, which has different topics such as R packages, data visualization, data wrangling, and machine learning. Thank you very much for watching the video.